Okay, we are going to start Chapter 5, Lesson 2, adding, subtracting, and multiplying polynomials. Okay, two learning targets. First is that you can do all three of those operations with polynomials. And then lastly, when we're going to take a binomial to a power, we want to use this thing called Pascal's triangle to expand the polynomials because it moves much quicker than multiplying it by itself over and over and over again. Okay. And when you arrange the coefficients of variables in this expansion of a binomial to a power, you'll see a special pattern, and that's called Pascal's triangle. Okay, when we're adding and subtracting polynomials, the thing that's really nice about that is it's basically combining like terms. It is finding the terms that can be combined together and then going ahead and doing that. So if I'm looking at example 1, I have 3x to the third power plus 2x squared minus x minus 7, and that polynomial is being added to the polynomial x to the third minus 10x squared plus 8. Now, as I look at this, when you're adding, it doesn't really matter what order you're adding in, so we can essentially think of this as all of these terms being added and subtracted together. We really don't need the parentheses. So we can just go ahead and find the terms that combine together. For example, 3x to the third power is only going to combine or add to other terms that are x to the third power. Otherwise, they're not like terms, and they can't be combined. So the only other thing that's going to combine with it is x to the third power. So 3x to the third power plus a positive x to the third power, that's just going to be 4x to the third power. Okay, what about 2x squared? Okay, so what if I have positive 2x squared? That can only be combined with negative 10x squared. Okay, and so as I'm looking at this, 2x squared minus 10x squared, those are going to combine into negative 8x squared. Okay, lastly, if I look here, this minus x, that doesn't combine with anything. There's no other just x to the first power. Since it doesn't combine with anything, we're just going to go ahead and bring it down as minus x. And then lastly, we have minus 7 and positive 8. Okay, those can combine together as well. They're like terms. So negative 7 plus 8 is minus 1. Or plus 1, positive 1, my bad. Okay, and then make sure your final answers here are written in polynomial form, meaning highest exponent to lowest exponent. Okay, so the only thing that can be kind of tricky about this is when we're subtracting. When we're subtracting, you have to be slightly careful because you can't just subtract in any order. For example, 3 minus 2 is not the same as 2 minus 3. So what we have to do is when I have this polynomial here and I'm subtracting this polynomial, okay, we need to go ahead and subtract each part individually. So a lot of times subtraction, I personally just like to rewrite it. This first part's going to stay the same. Okay, but then when I need to subtract positive 2x cubed. So if you look inside the parentheses, I'm subtracting a positive 2x cubed. So that's going to end up being minus 2x cubed. Okay, and then if I'm subtracting a positive 6x squared, that's me subtracting 6x squared. And if I'm subtracting a negative x, that's the same as me adding x. And if I'm subtracting a positive 1, that's the same as me minusing 1. Okay, so really, if you notice, all I did here is I just distributed a negative 1 to each of these. All of these just changed the sign. Okay, now that I've done that, I've distributed this negative, I've changed this into, just me subtracting and adding where necessary. Now I can combine my like terms. Okay, so for example, I have 8x cubed can be combined with negative 2x cubed. So 8x cubed minus 2x cubed, or plus negative 2x cubed, is 6x cubed. Okay, what about here? Negative 3x squared. Negative 3x squared can be combined with negative 6x squared. Negative 3x squared minus 6x squared that would be minus 9x squared. Okay, negative 2x can be combined with positive x. So negative 2x plus x would be negative 1x, or just minus x. And then lastly, we have positive 9 and negative 1. That combines into 8. Okay, now I'm giving the visual here for your understanding. Don't feel that you're required to do that. I want you to be able to do these problems however best fits you. Okay, so why don't you all take a moment and try A and B on your own and check it in with me when you are done, which I am going to go ahead and assume is right now. Okay, so here on A, I am subtracting. So I need to rewrite this second part here. So I'm going to go ahead and go 3t cubed plus 8t squared minus t minus 4, and then minus 5t cubed plus t squared minus 17. So again, I just did the same thing I did up here. I just distributed this negative. So the opposite of 5t squared is negative 5t squared. The opposite of negative t squared is positive t squared. The opposite of 17 is negative 17. Okay, then I can combine my like terms. We got like terms here and here. So 3t and negative 5t, that's negative 2t cubed. Okay, and then I have 8t squared and t squared. Okay, that is 9t squared. Okay, and then I have minus t. Well, there's no other term that goes with that, so it's just going to be minus t. And then lastly, I have minus 4 and minus 17. Okay, that would combine into minus 21. Okay, letter B. When I look at letter B, I'm adding, so I don't have to worry about changing the sign. I can just go ahead and combine the terms that are alike. So here I have 2x squared, a positive 2x squared, and a positive 7x squared. So that's going to combine into 9x squared. Here I have minus 6x and minus x. That is going to combine into minus 7x. Okay, and then lastly, it looks like I have plus 5 and minus 9. And those are going to combine into, there's 4 more negatives, so minus 4. Okay. And again, all of these written in polynomial form. That's the standard form I want everybody writing their work in. Okay, this, in all honesty, should come pretty easy to you. It's very, very consistent with us adding and subtracting any other type of terms that we've had together in the past. Okay, let's multiply polynomials. Okay, when we multiply polynomials, typically we've used the box method. Like when we would go x plus 2 times x minus 3, we would set up a box, and that same thing is going to be true here. We are going to also use the box method. It's just instead of a literal square, this time it's going to be different. We have a 3-term times a 2-term. So when we are multiplying, that means my box I'm going to have is going to be a 3 by 2 box. Okay, so here we have a 3 by 2 box now because I have a 3-term times a 2-term. If you had a 3-term by a 3-term, you would use a 3 by 3 box. Okay, so I'm going to go ahead and put minus x squared here, plus 2x plus 4, and then x minus 3. Okay, and so then we can just go ahead and do the same thing. X times negative x squared, well, that's going to be negative x cubed. X times 2x would be plus 2x squared. X times 4 would be 4x. Negative 3 times negative x squared, well, negative times a negative is a positive, and then that would be positive 3x squared. Negative 3 times 2x would be minus 6x. And then negative 3 times 4 is negative 12. Okay, now we have to combine like terms. If you set each term up in polynomial form, you're going to notice that diagonals are going to be the parts that add together. Okay, you're going to notice that those are going to be the terms that are alike. Okay, and also assuming that we're not skipping a term. Okay, so my last final answer is going to be minus x squared. 3x squared and 2x squared added together, that'd be 5x squared. Okay, I accidentally wrote squared here, but I did fix that to a cube because it should be cubed. Okay, negative 6x and positive 4x would be negative 2x. And then just negative 12. Okay, and that's basically how you do it. Now, when I have three terms all being multiplied by each other, it's really not any different. It's just you have to do the process twice. So I'm just going to go ahead and I'm going to start by multiplying these two parts together first. Okay. So when I'm doing those two parts first, that means I'm going to have a 2 by 2. That means I'm going to have y plus 5 and 2y minus 2. 2y times y is 2y squared. 2y times 5 is 10y. Negative 2 times y is negative 2y. Negative 2 times 5 is negative 10. Okay, and so this here is all going to come, well, my diagonals, again, have like terms. So I can go ahead and combine into 2y squared plus 8y minus 10. Okay, and now that's just these two multiplied together. So instead of these two, I have 2y squared plus 8y minus 10. And then lastly, what I need to do is I need to take this here and I need to multiply it by 3y plus 4. Okay, so that means I'm going to have a 3 by 2, the same thing that we just did over here. Okay, and let's go ahead and do that. So I'm going to have 2y squared plus 8y minus 10 and 3y plus 4. Okay, so 3y times 2y squared, that's going to be 6y to the third power. 3y times 8 is going to be 24y squared. 3y times 10 is negative 30y. 4 times 2y is going to be 8y squared. 4 times 2y squared, I misspoke. 4 times 8y, that would be 32y. And 4 times negative 10 is negative 40. And again, I have some like terms here in my diagonals. Okay. And so since those are like terms, I can combine them. So my final answer is going to be 6y to the third. 24 and 8, that's going to be 32. So I have 32y squared. 32y and negative 30y, that's going to be positive 2y. And then just negative 40 or minus 40. So all three of these terms here are just going to be multiplied into 6y cubed plus 32y squared plus 2y minus 40. Okay, what I would like you to do is pause the video and go ahead and try letters C and D on your own and then check it with me right now. We have three terms here, so that means I am going to go ahead and multiply twice to get to my answer. Okay, so I'm going to go ahead and do that. So I'm going to have x minus 2 and x minus 4. This is just the same that we've taught in the past. X times x is x squared. X times negative 2 is negative 2x. Negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. So now we're getting x squared minus 6x plus 8 because these diagonals are like terms. Okay, so then I can take this here and I can go ahead and multiply it by x minus 5. So this is x cubed minus 6x squared plus 8x. And then negative 5x squared plus 30x. And then minus 40. Okay, and then I have two pairs of like terms. I have like terms here that can be combined. And then I also have like terms here that can be combined. Okay, so then I'm going to get x cubed minus 11x squared plus 38x. Then minus 40. Okay. So, then lastly, we have D, which is just a binomial times a trinomial. So a binomial times trinomial, we're going to multiply using the box method, again, a 3 by 2. Okay, so I get 3y squared minus 2y plus 2, y plus 5. Okay, y times 3y squared is going to be 3y to the third power. Y times negative 2y is negative 2y squared. Y times 2 is 2y. 3y squared times 5 is 15y squared. 5 times negative 2y is negative 10y. And 5 times 2 is 10. Okay, and then again, I have multiple pairs of like terms here. Okay, always double check and make sure they are indeed like terms for you to combine. So then here I'm going to get 3y cubed plus 13y squared minus 8y plus 10. Okay, this is 13, positive 15, and negative 2. And then negative 2 and positive 2, or negative 10 and positive 2 is negative 8. Okay, so those are the answers, and those are just the fundamentals of what we're doing. Really, I think that this shouldn't have been too big of an issue for us. Okay, now let's go on to Pascal's triangle. All right, Pascal's triangle, it's kind of a unique thing because what we end up having is it's a very distinct pattern. So if I'm just, let's just say I start with ones here. I can go ahead and kind of fill out the rest. So if I have a 1 here, if I want to get this middle part here, I would add, if I want to get this middle part here, I would add these two parts together. So 1 and 1 is 2. Okay. And then here, if I'd get this would be a 1, because like 1 and 0 and 1 and 0. Okay, but then if I want to get this one, I'm going to add these two together. So this is going to be 3. And then this would also be 3. Okay, so again, we have 1s here. And then here we would have 1 and 3, this is 4. 3 and 3, which would be 6. And then 3 and 1 again, which would be 4. Okay, now if I have here, this would be 1, and this would be 5, this would be 10, this would be 10, this would be 5, and this would be 1. Okay, and what this does is this actually gives us the coefficients of our binomial expansion. So if I were to take, for example, x plus 1, and I'm taking it to the 0 power, okay, so if I take a plus b or some binomial and I take it to the 0 power, okay, anything to the 0 power is 1. Okay, so what's that binomial expansion? It just turns into 1. Where do we see that? We see that right here. So this is right here, this is the 0 degree row. Okay, well, what if I want to take it to the first power? Okay, if I take a plus b to the first power, okay, if I take a plus b to the first power, that is just going to end up being a plus b to the first power. Okay, and if I do that, I don't have to do any work. That's just going to end up being a plus b, or specifically 1a plus 1b. Where do we see 1 and 1? Well, we see it right here. So this is my first degree row. Okay, now I'm going to get a sheet of paper so I can expand these by hand so we can see where all of this is coming from. All right, let's go ahead and put this over here. Okay, what about if I want to take it to the second degree, or the second degree row? Okay, that means I'm taking my number a plus b and I'm taking it to the second power. Let's go ahead and see what that looks like. So that means I am going to go ahead and take a plus b and multiply it by a plus b. Well, a times a is a squared. B times A is BA. A times B is also BA. B times B is B squared. So what does this turn into? This turns into A squared plus B times A plus B times A. That's two of them. So I would have 2B times A plus B squared. Okay, so what do I end up having here? I have 1A squared plus 2BA or AB plus 1B squared. Where do we see that? We see that here. Okay, this is my second degree row. All right, so this would end up being 1A squared plus 2AB plus 1B squared. Okay, now what if I want to do that 3 times? Okay, that means I'm taking A plus B to the third power. Okay, you can already guess that this is going to be my third degree row, but let's see that happen. Okay, so if I'm taking A plus B to the third power, okay, what I'm going to do is I'm going to take A plus B, okay, because that's the same as this. Right? Well, we've already done this part. We know that this is the same as this. So now I'm going to go ahead and say this is A squared plus 2AB plus B squared. And I need to multiply it by A plus B. Okay, because we already know that this is what this is equal to. We just did that. A plus B times A plus B is right here. And again, BA and AB are the same thing. Okay, so now I have to take a trinomial and multiply it by a binomial. So I get A squared plus 2AB plus B squared. And we're going to multiply by A plus B. Well, A times A is A cubed. A times 2AB is 2A squared B. A times B squared is AB squared. B times A squared is A squared B. B times 2AB is 2AB squared. And then B times B squared is B cubed. And then we have like terms. We just did this a second ago. We have like terms here, and we have like terms here. Okay, so what we're getting is A cubed plus, well, I have 1A squared B here, and I have 2A squared B's here. So altogether, I have 3A squared B's. And then the same thing here. I have 2 of them here and 1 of them here, and now I have 3 AB squareds, and then I have a B cubed. Okay, so this is what this is equal to this. So 1A cubed plus 3A squared B plus 3AB squared plus B cubed. Okay, and as you can see, this is the third degree row. Just because, and this will be the fourth, and this will be the fifth degree. Okay, now here's the thing. I don't want to have to do this every single time I have to expand a polynomial. If I have some A plus B cubed, I don't want to have to like do the first two together and then take that result and do the third one. Or what if I had the fourth? What if I had to the fourth degree? I would have to take these two, get this, then I would have to multiply by this, get this, and then I would have to take this and multiply by A plus B again. That's too much work. As opposed to, there is a distinct pattern. Let's see if we can see the pattern here. So we're going to figure out the fourth row without having to multiply them out. Okay, so as you can see here, I have A's and B's. And what's happening to my A's? As my A's from left to right the exponent is decreasing. So there's no exponent here. Exponent of 1, then no exponent. Exponent of 2, exponent of 1, no a at all. Here, exponent of 3, exponent of 2, exponent of 1, no a value at all. Let's think about the b values. The b values, no b value at all, and then a b value of 1. No b value of all, b value exponent 1, b value exponent 2. So it's starting without it there, and then it's increasing by 1 each time. So here, no b value at all, b value of 1, b value of 2, b value of 3. So I know that my a's are going to, and look here, my degree is 3, so I start with 3. My degree is 2, so I start with 2. Degree value 3, end with 3, b value of 2, or exponent of 2, degree is 2, ends with 2. Okay, where are these numbers coming from? Well, they're coming from the cells inside Pascal's triangle. Okay, so we can already go ahead and start this. Okay, my coefficient on the 4th degree row is going to be 1. So 1, and my degree is 4, so we're going to start with a to the 4th. And then there's no b here because the b starts at 0. Okay, so let's do the second one. So the second cell is 4, so we're going to have a 4. And then a should decrease by 1, so a to the 3rd. And then the b value should increase by 1. So b value exponent 0 to b value 1. Okay, let's do the third cell, 6. Okay, a value is just going to keep decreasing. So a to the 4th, a to the 3rd, a to the 2nd. B to the 0, b to the 1st, b to the 2nd. Okay, next cell is a 4 again. A to the 4th, a to the 3rd, a to the 2nd, a to the 1st, b to the 0, b to the 1st, b to the 2nd, b to the 3rd. Lastly, 1, so again another 1. I'm going off the charts here, that's okay. B to the a to the 4th, a to the 3rd, a to the 2nd, a to the 1st. I'm not going to write a. It's gone, a to the 0. Okay, what about b's? B to the 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th. Okay, and so that's the pattern, and that's how we can do this. Okay, so all we have to do is know what these values are. Okay, let's go ahead and try that. Okay, so here I have z plus 3, so my a value here is z, and my b value here is 3. Okay, and I'm just going to go ahead and use Pascal's triangle. So I'm taking it to the 3rd, so I'm looking at the 3rd degree row. So 0 degree row, 1st degree row, 2nd degree row, 3rd degree row. Okay, so I'm going to start with 1 times a to the 3rd power. And I'm going to add to it, well, a is z here, so let's go ahead and go 1 times z to the 3rd. Okay, and then I'm going to add to it the second cell. Here's 3. So it's going to start with 3 times a to the 2nd, right, because my a value is decreasing by 1. So z squared times the b to the 1st power. So 3. So here is like, this right here is my first cell. This here is my second cell. Let's go ahead and do my third cell. It's going to start with a coefficient of 3. So 3 times z to the 3rd, z to the 2nd, z to the 1st, times b, b to the 0, b to the 1st, b to the 2nd. This is my third cell. Okay, and then lastly, cell is 1, so it's going to start with a coefficient of 1. B, or z to the 3rd, z to the 2nd, z to the 1st, no z at all. 3 to the 0, 3 to the 1st, 3 to the 2nd, 3 to the 3rd. That's my third cell. Okay, and all we have to do is simplify. Okay, 1 times z cubed is going to be just z cubed. Okay, 3 times 3 is 9, and then 9 times z squared is 9z squared. Okay, 3 squared is 9, times 3 again is 27. Z, and then 3 to the third power is 27 times 1 is 27. Okay, so instead of multiplying z plus 3 times z plus 3, and then taking that result and multiplying that by 3 plus z, this pattern ends up going a little bit faster. And we see it get a little bit faster the higher degree we have. Okay, so this one in general is a little long, and it's going to take a little bit of space, so you might want to write pretty small. Okay, so here my a value here is 2t, and my b value here is -1. Okay, and then that means we're going to the 5th degree because my exponent is 5. Okay, and so then here we're going to use a 5th degree row. Okay, so we're going to a values start high and end low, and b values start low and end high. Okay, so let's go ahead and start this. We're going to start 1 times 2t to the 5th power plus 5 times 2t to the 4th power, and then times -1 because my b value isn't there at all, so now it's going to have a -1 there. Okay, we're probably going to end up writing this way and having to wrap it down below because I'm already pretty sure I've ran out of space. Okay, so then 10 here. Okay, so we're going to go 10 times 2t to the 3rd, and then times -1 squared. So here's my first cell, here's my second cell, here's my third cell. I'm going to go ahead and write my 4th cell down here, plus 10 times 2t to the 5, 4, 3 second power times -1 to the 0, 1, 2 third power. Okay, that's my 4th cell. 1, 2, 3, 4. Okay, so now we're on the 5th cell. So that starts with a 5 times 2t to the 5, 4, 3, 2, 1. So I just get to leave that. Times -1 to the 0, 1, 2, 3, 4 power. That's my 4th cell. Okay. And then plus 1 times 2t to the 5, 4, 3, 2, 1, 0. I don't even have to write it. Times -1 to the 0, 1, 2, 3, 4, 5th power. That's my 5th cell. Okay, so let's go ahead and simplify this. Okay, so here we have to go 1 times 2t to the 5th. So that means I got to figure out what 2 to the 5th power is. Okay, so we are going to have 2 to the 5th power, which is 32. Okay, so this is first part. This first cell is 32 times t to the 5th power plus, okay, here we're going to have to go 2 to the 4th power. Okay, 2 to the 4th power. And then we're going to have to go times -1 and then times 5. Okay, 1,280 t to the 4th. Okay, here we're going to have to do this here. So we're going to have 2 to the 3rd power times -1 squared times 10. That's 80. And then t to the 3rd. Okay. And then here we have 2 squared, so we gotta go 2 squared times negative 1 to the third power times 10. Negative 40. I believe this needed to be negative. We'll go back and double check this cell here. Okay, negative 40 t squared. And then last here, 1, 2, 3, 4. Okay, so now we're here. Okay, we got to go negative 1 to the fourth power. Is 1 times 2, and then times 5. Okay, which is 10t. And then negative 1 to the fifth power times 1 is negative 1. Okay, I believe we need to double check this. I think I forgot to write a negative. Let's go ahead and do this one again. So 2 to the fourth power, so 2 to the fourth power, okay, times negative 1 times 5, which is negative 80. Yeah, okay. Negative 80. So, let's double check. 2 to the fourth power times negative 1 times 5, negative 80. Okay, let's double check this one. 2 to the third power, 8 times negative 1 squared times 10. Okay, perfect. Okay, so we did just miss, I must have thrown something wrong in the calculator here. Okay, so we can simplify all this. This is going to just be 32 t to the fifth minus 80 t to the fourth plus 80 t to the third minus 40 t squared plus 10t minus 1. Okay, now if you wanted to, you could take 2t minus 1 times 2t minus 1. And then you can take that answer, go 2t times 2t minus 1 and get an answer. Take that answer, multiply it by 2t minus 1. And then take that answer and multiply it by 2t minus 1. And it'll get you the same answer. Okay. Folks, I think it's time for you to try E and F on your own. All right, and then check it with me when you are done, which I'm assuming is right now. Okay, so here I have an A value of 3y and a B value of 1, and I'm going to the fourth degree. Okay, I'm going to go ahead and use this as my fourth degree here so I don't have to go up and steal the numbers out and move my paper back and forth. So I'm going to have 1a to the fourth power, so 1 times a to the fourth, so 3y to the fourth power, plus 4 times a to the third power, plus 4 times a to the third power, a value 4, a value 3, b value 0, b value 1, so then times 1. Okay, here's my first two cells. Here's the first cell, here's my second cell. Okay, plus 6 times a squared, so 3y squared, a value 4, a value 3, a value 2, b value 0 to the 0 power, b value to the first power, b value to the second power. Okay, I'm going to continue my work down below here. Okay, 4ab cubed, so plus 4a, 3y to the first power, so a to the fourth, a to the third, a to the second, a to the first, times b, b to the 0, b to the first, b to the second, b to the third. Okay. Plus 1 times a to the fourth, a to the third, a to the second, a to the first, no a at all, no b at all, b to the first, b to the second, b to the third, b to the fourth. That's my third cell. Okay, let's simplify this. 3y to the fourth power, so that's going to be 3 to the fourth power, which is 81, so 81 y to the fourth. Okay, here we got to go 3 to the third power, so 3 to the third power, 3 to the third power, and then multiply that by 4. And then times 1, that's going to keep it alone, so that's going to be 108 y to the third. Okay, 3 to the second. Okay, 3 to the second times 1 to the second well, 1 to the second's 1, so 3 squared times 1 is 9 times 6, which is 54. Okay, here 3 to the third is 1. 1 times 3 is 3. 3 times 4 is 12, so 12y. And then 1 to the fourth is 1 times 1 again is 1. Okay. Let's do f. F is a trinomial, so that means my a value here is x, and my b value here is -5. And we're going to the third power. Okay? 1, 3, 3, 1. Okay. So we're going to have 1 times a to the third power, and that's it. I don't have to write b because b starts low, a starts high. Okay, plus 3 a to the third. Now we're going to go a to the second, and then b to the first power. Okay, first cell, second cell. Okay, and then we're going to start again with 3. So 3 times x to the first, so x to the third, x to the second, x to the first, b to the 0, b to the first. Next is going to be b to the second. All right. And then lastly, let's see if I can squeeze it in here. A, so 1 here, 1. Okay, a to the third, a to the second, a to the first, no a value at all. B to the 0, b to the first, b to the second, b to the third. Okay, that's -5 to the third power. Okay. So here, 1 times x cubed is x cubed. 3 times -5 is -15. Then x squared. -5 squared in parentheses like that is 25. 25 times 3 is 75, so plus 75x. And then -5 to the third power is -125. All right, that's it, folks. Now, this last page is probably going to be the one page that's going to give you the most fits, but it's definitely doable. So I would encourage you all to move on to the homework, and I will see you next time for the next section.